The question that I have is, could you illustrate the vector method of finding moment via an example? Here is a summary of the equations relevant to the vector method of finding the moment of a force. Referring to this picture, moment about point O of this force F is given by this equation, MO equals R cross F, and R cross F eventually works out to be in this component form. And here is a method of finding the R cross F. Once we find the moment about point O, we can find the moment about this axis, the A axis, by this equation. MA is simply UA dot MO, where UA is the unit vector along that axis. To evaluate this dot product, we can either first find MO in its component form like this, and then find the dot product between the two, or we can use this simplified direct expression for the dot product between UA and MO. Let's go ahead and solve this 2D problem by the vector method. We did this by the scalar method, and we got a value of minus 460 Newton meter for the moment about point O for the force 100 Newton, right? Here we will do this by the vector method and see if we get the same number. First, let's go ahead and define a coordinate system like shown in this picture. So I'm going to take my x-axis to be in that direction, y-axis to be vertical, and the z-axis is one that comes out of the paper, perpendicular to the paper, and comes out of the paper. Also remember, once we select the directions for the x and y axes, then the direction of the z-axis is defined uniquely. It's not arbitrary. If you recall, we used the right hand rule to define that, right? So you hold your fingers going from x to y, and then your thumb will tell you the direction of the z-axis, right? Our next step is to define this vector r, all right? So to do that, we have to define 2 points, point O and point A, and point O should be chosen on the axis about which we are interested in finding the moment. We are interested in finding the moment about point O, which we know is actually a moment about the z-axis, right? And therefore, point O should be taken on the z-axis. All right, so I'm going to take this origin as the point. And now I'm going to take this point, point A, as the point at the end of the r vector, since we know the coordinates of this point, right? This is the x-coordinate, that's the y-coordinate, right? The point at the end of the r vector could be any point on the line of action of the force F, and A happens to be the most convenient point. Now recognizing that the x-coordinate of this point is 5 meters, y-coordinate is 2 meters, and the z-coordinate is 0 because this point happens to lie on the xy plane, right? We can write down an equation for the r vector. So it will be 5 times I plus 2 times j plus 0 times k. And all of these numbers are in meters. Our next step is to go ahead and write the force vector in its component form. And here are my calculations for that. So obviously we have to resolve this into components. So that's my x component, 100 times 4 over 5. And my y component is 100 times 3 over 5, but going down, and therefore it's a negative component. And the z component is 0, again because of the fact that this vector lies on the xy plane. Now you construct your f vector using the component. So x component multiplied by I minus y component multiplied by j plus 0 times k. Simplify this a little bit, so we get this for the force vector. Now let's go ahead and find the moment vector about point O by the determinant method. So here I form my 3 by 3 determinant. The first row has I, j, and k. The second row has the components of the r vector, which are 5, 2, and 0, 5, 2, and 0. And the third row has the components of the f vector, which are 80, minus 60, and 0, 80, minus 60, and 0. So to expand this, I copy this 3 times and strike out these rows and columns, right? And then come up with this equation that contains the 2 by 2 determinants. So in the first case, these are the leftover numbers. In the second case, this 5, 0, 80, and 0 are the leftover numbers. In the third case, 5, 2, 80, and minus 60 are the leftover numbers. Also, we have a positive sign here, negative sign here, and a positive sign here. So after simplifying, I get this equation. So we get 0 component in the x direction, 0 component in the y direction, and minus 460 in the z direction, right? And therefore, my mz, which is the moment about the z-axis, is simply minus 460 Newton meter, which is what we got by the scalar method, right? So you can see the vector method can be applied to both the 2D and the 3D problem, but obviously it's a lot more useful for three-dimensional problems.